All right, yeah, today we have Charlotte with us,
Hello.
and Charlotte will tell us about one of her recent publications, which is, I think, a very important one on impulsivity and inhibitory control. So, what's in a nutshell what you found out there?
Mhm. Well, we investigated how we deal with interfering perceptual information while controlling our actions. You can imagine a traffic scenario as an example, where there's a pedestrian just about to cross the road since the traffic light shows green. But simultaneously, the sound of a fast approaching car signals them better not to do so. So the pedestrian receives conflicting information on how to solve the situation and should inhibit their impulse to cross the road. And what we found is that not only the reaction to a conflict is of relevance, but on a neurophysiological level, there's also a more general preparatory state which is important for this conflict resolution.
Okay, but what do you mean with this preparatory state? So, is it sort of a brain state that occurs before and which is in somehow determining what's happening thereafter, or how well you can cope with that?
Yes, that's basically what we found out. Before I tell you more about that, it is also important to know how communication functions in our brain, and it is organized through a so-called oscillatory activity. So the neurons in our brain communicate via changes in their electrical potential, and depending on the frequency of these changes, different I would say, brain functions are enabled.
Okay.
And for situations like the traffic scenario, it is very important to have anticipatory information gating processes, which can be seen as sort of a filter in our brain. And they selectively let relevant information pass, but not irrelevant information. And what we found is that people with strong proactive information gating perceive the conflict stronger and thus realize that they need to adapt their action plan.
Okay. And what about the frequencies specifically? What are these frequencies?
Well, in our study, we found that specifically an interaction between theta frequency band and alpha frequency band are important when it comes to the resolution of conflict during inhibition.
I see. So basically, there are two sorts of communication, you may say. One is related to alpha, one is related to theta, and they are, let's say, mediating two distinct but nevertheless important cognitive functions to,
Yes.
let's say, cope with that situation. But I would think that this is only half the story because, I mean, there need to be some brain regions associated with this sort of activities and let's say the interplay of these activities. But
Yes.
what are these?
I can show you right here. For the proactive information gating, there is the primary motor cortex located about here, which is very important. It is associated with planning and preparation of motor responses and actions. And after people perceive the cognitive conflict or the perceptual conflict, they transfer the need to adapt their mental representation of the action plan to a region called the midcingulate cortex, which is located right in the middle of the brain, about here. And it's suggested that perceptions and actions are integrated in this brain region so that an action plan can be formed.
All right, so you have two distinct, let's say, ways to code this information in alpha and theta band activity, and then you have an interplay between motor cortical areas, which makes sense because you are about to inhibit a motor response in some sense, yeah, but also an area where all of these informations need to be integrated beforehand, you may say,
Yes.
in order to accomplish that. So, but how exactly did you find that out?
We investigated 50 healthy adults who performed a reaction task on a computer, a go-no-go task, and we recorded their EG activity while they were performing the task. But the go-no-go task was not that simple. There was a perceptual conflict with it, so participants received visual stimuli and auditory stimuli, which either indicated to press or not to press a button. And for example, when a visual stimulus showed to inhibit the response, not to press a button, but simultaneously an auditory stimulus told the participant to press the button, there was a perceptual conflict, which made it particularly difficult to react correctly.
I see, but I mean, to be honest, I mean, go-no-go tasks are all the way around. Yeah, it's a very prominent task in cognitive neuroscience, may it be in EEG research, may it be in fMRI research. So, what's the innovation when you think about that task and what you did? I mean, it's always there. So, what makes it so special? What you found out?
You're definitely right that response inhibition go-no-go tasks, they have been thoroughly investigated. But previously, the studies have focused on neurophysiological processes occurring while we inhibit responses.
Okay.
What was new about our study is that we additionally investigated preparatory brain states, so proactive control, so happening right before we inhibit an action or before we even perceive a hint on doing so. So this is the new part. Why is it so important? Paradoxically, it has been the case that in EEG analysis procedures, we usually use time windows exactly before we perceive a stimulus as a baseline signal. That means we have been assuming that nothing of relevance happens in these time windows. But this study shows that there are many important things happening for action control exactly in this time windows.
Okay, I see. So you are kind of opening the horizon. Yeah. I mean, it is in fact a bit weird to think that there is some activity which is of no use in the brain, but you are right that people have been treating this activity as such. But now you show, well, it's perfectly important for the processes occurring thereafter. And I could imagine that this is also of relevant when it gets to, let's say, some application fields or when you go to clinical neuroscience, or am I wrong?
No, definitely. I mean, a first step is that we have to do another study where we investigate whether these neurophysiological processes are also shown at the behavior level. So whether people who have a high proactive information gating actually can control their actions better than people with a lower proactive information gating. If this is indeed the case, a next step would be to examine whether we can train or enhance or modify this proactive information gating processes. You could do this with cognitive training, for example, or with neurofeedback.
So the idea would be not to focus on what has been around, but to say, well, we need to a bit earlier on in order to, let's say, prevent things to happen, which doesn't mean, okay, to prevent a disorder, but to prevent, let's say, if an upcoming situation may be conflicting, then it's already prepared early on in the brain state right before, yeah, and not just while I am confronted with that problem.
Exactly. Yes, and this could also have implications for clinical research, since we know that there are several psychiatric disorders with or accompanied by difficulties in exerting cognitive control. Just think of ADHD or schizophrenia. So we should also examine whether people with and without these disorders show differences in proactive information gating.
Fascinating. Yeah. So I think there are many things on your list,
Yes,
that are worth looking into in the future. Thank you very much
Thank you.
for these really great insights, and thank you very much for watching us.